Woohoo, and welcome back. Today we're doing 9.7 exponential and logarithmic equations. Woohoo! And for this section, we're going to take everything we've learned in this chapter, bring it all together to solve some more interesting equations, which I know you were all looking forward to. You all woke up today thinking, wow, I hope today brings me more interesting equations. And you're in luck. It is. So we're going to start off, and I'll remind you when we start off, if I use the word simple, simple doesn't necessarily mean easy. It means fewer steps. So that's what I mean when I say solving simple exponential equations. So we're going to start off with equations that do not require any special properties or any logarithms. Woohoo! That'll be later. I know, something to look forward to, even more excitement. So the second thing I want to say is when I say solve for x, and at this point you've been solving for x for years, but let me remind you that all we're trying to do when I say solve for x, that means get x by itself. That's all you're trying to do. You just want to isolate x. So whatever means possible, as long as it's logically true, you're allowed to do. So what does that even mean? Okay, so let's look at the first one. 4 to some power is 16. Now I'm hoping that when you see that, you're looking at that going, oh, well, 4 squared is 16. And the answer is yes. But can you write that down? Like, it's fine to just say, oh, x equals 2. But can you fill this space with some more thought processes so that people reading it understand how you figured out it was 2? Because someone might look at that and go, oh, I don't know. So let's figure out a way to write this down to get x by itself. So I've got 4 to the x on the left. There's not a lot I can do with that, but when you're working with exponents, it can be very helpful to make sure everything is written in the same base. So I see over here I've got a 16, and I know that 16 is 4 squared. So if I start off with 4 to the x equals 16, I could say 4 to the x equals 4 squared, right? Because 16 is 4 squared. But then I can say, wait a minute, and this is perfectly legal. You are allowed to do this. 4 to the x equals 4 squared. Well, then x must be 2. Does that make sense? So this way I'm not just simply writing, oh, x equals 2. I'm writing in my reasoning, so anyone reading it could follow it along. So far, so good? And I know you can't answer. You might be screaming, no, I have no idea what you're talking about. If you are currently screaming at the computer monitor or your smart device, put the device down, turn off the monitor, walk outside, breathe in some air. If it's raining, take an umbrella. If it's snowing, I don't know what to do in the snow. I live in California, in a place where it doesn't snow. So I have no idea. I don't know. Get a monster truck. Go outside, get some fresh air, find a dog or a cat, some animal that will let you pet it, go for a walk, go for a run, go for a sit down, go for a meditation, do some art, come back, and then write me an email or send me a message and say, what the heck is going on? Okay? Because this is going to escalate quickly. This section is going to be an exciting one. And the homework may be exciting. I know you were excited about that. So if you have questions, if what I've written isn't enough, contact me, contact a tutor, reach out, get some help. The goal is not for you to be miserable. The goal is for you to say, oh yeah, I see what you did there. Awesome, rock on. Okay, shall we try again? Woohoo, number 2. So I've got this one, and I'm not going to hyperventilate. It's a little bit of a lot. And again, I've mentioned this before, but I always take whatever's written, and if it seems a little scary, I write it extra big. That way nothing can hide, right? Just face it. Face this math. And I see that my bases do, in fact, match. As long as your bases match like they did up here, life is good. And so that means I've got these matching exponents. Woohoo! Okay. 2x equals -8. Well, what I've done is I've taken a very complicated looking equation and I've come up with a similar and equivalent equation. That's a lot easier to solve. I know what to do with this. I'm going to divide both sides by 2. Now notice with both of these examples, I'm not doing anything to both sides of the equation. I am simply seeing that if I've got matching patterns, then the pieces of the pattern match up. I can do this with exponentials. You can't always do this, right? It doesn't always work. It just works with exponentials. So you've got permission to do it in this particular case. Now, how do you make sure it works? Well, what you could do in both cases, we can go back in and check. So we could write over here. Can you see this? Let me scooch this sideways. Okay, so I'm going to check. 4 squared, does that equal 16? And the answer is yeah, 4 squared is 16. That was a really fast check. Let's try this one. If I have 4 to the 2x equals 4 to the -8, and I've got, I should have put a box around these answers so that you can see them more clearly, and we've got x equals -4, then that's 4 to the 2 times -4. Does that equal 4 to the -8? And this is 4 to the -8. Yeah, that does equal 4 to the -8. Woohoo! 4 to the -8 equals 4 to the -8. So far, so good. So these two we did without any sort of special formulas or anything, just my permission that if you can get matching bases, then the exponents have to be equal. Matching bases means the exponents have to be equal. So far, so good? Okay, page 1. Deep breath. You can always pause this, go get yourself, something lovely to drink, something cozy to snuggle in, and oh man, this escalated quickly, did it not? And again, I know there's a lot of stuff going on in number 3. Let me write it big. I really, really do believe that changes the world to write it really big, really clearly. Okay, so in this particular problem, we don't have matching bases. So the question is, can I write this right side with a base of 2? And the answer is yes. 16, I happen to know, is 2 to the 4th. Now, how would you figure that out? Well, you would sit here and you would try different things. 2 squared is 4, 2 cubed is 8, 2 to the 3rd. Wait, 2 cubed is 8, 2 to the 4th is 16. There we go. Woohoo! Okay, so I've got 2 to the 6x equals 1 over 2 to the 4th. Okay, so we're partway there. We do have matching bases, but this is in a denominator. So this is not, these two aren't in the same format yet. So I can't do that magic trick yet. Okay, let's see. 2 to the 6x equals. Now, you have to remember that if something's in the denominator, the exponent is negative. So I just write it as 2 equals 2 to the 6x equals 2 to the -4th. Woohoo! We got them! Matching bases. Matching bases means matching exponents. Yay! So in other words, 6x must equal -4. And then our hearts sink a little bit because we're like, oh, that's not going to be nice. And it's okay. Sometimes numbers, not your favorite number. It's okay. Still works the same way. I'm going to go ahead and divide both sides by 6. Okay, so I've got x on the left, right, equals -4 over 6, which I can actually reduce, right, because I can go in and cancel 2 into 4 goes twice. 2 into 6 goes 3 times. So I've got x equals negative 2/3. Now, this one was enough of a bear that I'm really going to want to check it because there are a lot of steps in here. I want to make sure I didn't make any, little mistakes that I need to go in and fix. Mistakes happen all the time. So I'm going to say I've got 2 to the 6 times negative 2/3. Oh boy, this is going to be so much fun. Equals 1/16. Okay, so let me write this big. I've got 6 over 1 times negative 2/3. Okay, so what's going to happen there? Well, when you multiply two exponents like this, you can go ahead and cancel just like regular old fractions. The fractions here work just like regular fractions. So then I cancel the 3 and I get a 2 there, so I get 2 to the negative 4th, which I already know is 1/16, which is 1/16! Yay! I know I wrote that twice. That was kind of silly. I just got so excited. Sometimes you get excited and write things more than once. Woohoo! Okay, shall we go to the next one? Dun dun dun! You notice I gave this one a lot of space. I don't know if we'll need it. Let's see. This should be extra bonus fun. You guys ready for extra bonus fun? Oh my gosh, I know I am. This is pretty cool. Okay. So, again, I've got this exponential expression over here and then 16. And I already remember from up here 16 can be written as a power of 2. So I've got 2 to the x squared minus 3x equals 16. So 2 to the x squared minus 3x equals 2 to the 4th. And I'm using this from up here, or this here, wherever wherever you want to look to. 16 is 2 to the 4th. So I've got matching bases. Yay! So if we have matching bases, then the exponents must match. Hopefully you're getting the pattern here and you're starting to get like, oh, okay, this is just something, repetitive. It's like making, chocolate chip cookies every week. I don't know why I said that. I think I'm just hungry. So I set the exponent on the left equal to the exponent on the right. And oh my gosh, you guys know what to do with this. This is something we've been working on already. Yay, isn't that amazing? It's almost like the person writing the book realized that as soon as you learned this, you could do this kind of problem. Ooh. Okay, so now we've got a quadratic. This is a quadratic equation equal to 0. I know this doesn't always feel, it's like we started here, which looked a little bit dicey, and then we got excited, and then we're like, oh no. So I know sometimes making it better only makes it slightly better, but this is an equation we can solve. This, not something not something I can solve in my head. Perhaps you can. Okay, so let's go ahead and solve this guy. I'm going to hope that it's pretty simple, trial and error. It seems to be there's an x and an x, and I'm thinking a negative 4. A negative 4 could be minus 4 and plus 1. Does that work? Check the middle term. Minus 4x plus 1x. Yeah, that works. Okay. 0 property. Okay, plus 4, plus 4. So either x equals 4 or x equals negative 1. So far, so good? Woohoo! Shall we check? Always. Always check, especially when they're this complicated. And whenever you're checking, please do write the word check or put it to the side in a box, separate it somehow so that the person, your teacher, your professor reading it can follow your reasoning. You want to leave, just a little bit. Like the way I use my arrows, very, very sneakily, I use the arrow so that to read down and then read down rather than trying to read all the way across, which is the style I learned to do it in, vertically rather than horizontally. Okay, so I'm going to check x equals 4 first. So I've got 2 to the 4 squared minus 3 times 4. Is that equal to 16? So let's see. This is 2 to the 16 minus 12, which is 2 to the 4th, which is 16. Yes. Woohoo! Yay! We did it. Okay, let's try x equals -1. So 2 to the -1 squared minus 3 times -1. Does that equal 16? -1 squared is 1. -3 times -1 is +3. That's 2 to the 4th. We already know that equals 16. We did it! Yay! So now you can write your answer like this, or we could write the answer x equals -1 comma 4. Whenever you see a comma, it's an or. Commas in math are read as ors. And is a really weird word. In English, it means, you could have them together or separately. It just means they're both included. In math, and means both at the same time. It's a very intense sort of thing. If you want and, if you say that you like, for example, hot fudge sundaes and bacon, that means you have to eat them all together mixed up. And I know it sounds funny in English, but in math you'd say you like hot fudge sundaes or bacon. So to mean that you don't necessarily want to have them together, but you could. So this is an or. X is either -1 or it's 4. Okay. Deep breaths. Everyone ready? You know this is just going to escalate. It's going to escalate not that quickly. How quickly? Well, 17 minutes into it. Dun, dun, dun! And why did I make this scary music? You don't know. You can't see. I have put this off to the side where you can't read it. Oh, no. Are the bases matching? And the answer is no. Now, could you go to an extreme to come up with a way to make the bases match? Yes. Do we want to do that? No. Trust me, you don't. But given that we have to solve this, and again, remember, you want to get x by itself, but this is complicated. There are x's on both sides. So we're going to take a deep breath. You can do it. We're going to do great. This is going to be amazing. You guys ready? Awesome. There's going to be some massive awesomeness here. Okay, first off, I'm going to introduce my new puppet, Liam Neeson, who has a particular set of skills that he has acquired. Am I going to use this one? Oh, I'm not going to use this one. I lied. I thought I was going to use this one, but I'm not going to use this one. I had a piece of paper ready for you. And in fact, I put it in the picture I took, but it's not the one I want to use. So this is logarithmic form to exponential form. I grabbed the wrong one. Okay, so ignore that. But this is Liam Neeson. He has a particular set of skills. He wants you to let his x go. Okay. It's another movie. It's very exciting. It's very math-centric. He's going to follow and use logarithms. Dun, dun, dun. Pretty much, I guarantee you, if anyone is giving you trouble, like you happen to be in an action-adventure movie or something, use logarithms. Everyone's scared of logarithms. Okay, but we're not scared of logarithms. Let us look at that. I know, it's a lot. We're just going to breathe it in, breathe through it. You guys can do it. Okay. So you notice that the bases don't match. And I'm going to make a point of that right here. If the bases don't match. And you could point out, you could say, wait, the bases didn't match here. And the answer was yes, but we could make 16 into something that's with a base of 4. So here, it's going to be really hard to make the 5 into something that is base 2 to some power. So what are we going to do? Well, what we're going to do is use logarithms. Because I happen to know that when you take the log of an exponential, some magical things happen. And let me remind you right here, because I don't have the right one written out, remember that if we have log, and I'm just going to go ahead and say log base c of a to the bth power is equal to b times log base c of a. Do you remember that? And frequently I have this little green arrow pointing down. So in other words, this exponent comes down in front of the logarithm. And I will make this all pretty. I'll put lines around it and everything. I won't make you listen to it. Watch while I do that. But let me see if I can do this. Log base c of a, I'm going to have a, b, blue, to the bth power. Green, 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 coloring time. It's a good way to calm down, right? If your math is giving you trouble, do some coloring. I should create a wildly successful math coloring book. And a little voice in my head is asking, would I give it to children when they've been good or when they've been bad? But that was just me being silly. Of course, it's for when you've been good. Yay, excellent math. Woohoo, math that gets us out of a jam. Okay, there we go. So now I've got my little card. So what does this mean? If I apply a logarithm to an exponential expression, the exponent comes down in front of the logarithm. Okay, so now I've got an equation here. Am I allowed to just put a logarithm anywhere I want? And the answer is kind of. Remember the rule that you have to do the same thing to both sides. I'm going to tell you that at this level, I can't tell you why, but this is not exactly the same thing, but it's still allowed. Okay, you get special privileges with logarithms. So first thing is we have to pick a logarithm. I'm going to go ahead and use common log, LOG. Some people like to use natural log because it's shorter. It does not matter. Could you use log base 12? Sure, it's going to be harder, but you could. So what I'm doing here is I am applying logarithm. So I'm taking those two sides of the equation. Since they are equal, the logarithm of the left must equal the logarithm of the right. And now I know a lot of people are like, wait a minute, you took something horrible and you made it horribler. And the answer is yes, but only briefly. Remember what our goal is. Our goal is that Liam Neeson gets his ex back. He's on the phone. He's pretty upset. And he does have a set of very particular skills. So what are those skills? Well, they happen to be logarithms. Remember what happens to this exponent. The exponents, each of the exponents, they don't match. Maybe I should have done them in the same color. They're both exponents, but I'll make one the more yellow exponent. You can see they're related. And this one will be the more blue exponent. There we go. So they're related, similar, but not the same. So in each case, I took the logarithm and the exponents came down in front. What is the benefit? Because now, honestly, it just looks like things get worse and worse and worse. And the answer is maybe, but x is down on the ground here, x is down on the ground here. Here, the x's were floating in the air. We don't want that. We want to get all the x's together on the ground. So, you guys ready? I know this escalated very quickly, did it not? Okay, deep breath. Again, you can pause this anytime you want. You can rewind. You can go watch a Liam Neeson movie and then come back, get something nice to drink. And okay, you guys ready? Now, what we're going to do here because of this nastiness right there, is I'm going to multiply through. I know everyone's starting to throw things at the screen. What? Why would you do that? Okay, I'm going to multiply the log 2 times both of the things inside. So I get 2x log of 2 plus 1 times log of 2 equals, and then I can take this out of the x out of these parentheses because it's a single term, x log 5. I wrote in the multiplication there so it doesn't look like it's yog. It's the double L, Lye, I think. I don't remember. Sorry, I'm so sorry. Senorita Azevedo, I've forgotten what that letter is called. Oh, I'm so sorry. But so it's 1 times log of 2. And so what are we going to do there? Well, I've expanded this because now here's an x and there's an x. And we want to get the x's together. So we've got a couple of options. I think what I'm going to do, what am I going to do? I think I'm going to move this term over here to get the x's together. But I also think that I've got no more room. So I'm going to go ahead and come back over here. So I've got 2x log of 2 plus, this is 1 times log of 2, so it's just log of 2, equals x log of 5. Oh, you can't see that. Let me try this again. I just copied it back over again. Okay, so now what I'm going to do is I'm going to move the 2x log of 2, that's over here. So let's see what I've got. Over on the left-hand side, this cancels, so all I have is the log of 2. And then over here, I had x log 5, and I'm subtracting 2x log 2. And I know the way I wrote it there made it look like they could subtract. Could I subtract these? And the answer is no. These are completely different logarithms. They got nothing. There's no like terms here. This is just a mess. This is like x got involved in something very complicated, and it's going to take probably a few accountants to get them out. Okay, so what do I do when I've got a mess of junk and a bunch of x's mixed up in it? Accountants might help, but a mathematician would say, hey, you know what we could do? We could factor out the x's. Let's take a look at that. Let's take a moment. Over on the left, nothing has changed. I just moved this term over here. Then here on the right, I've got an x right there. What colors have I not used yet? Oh, pink. There's an x. There's an x. We factor it out as a single x. This is the sneaky move. This is gonna save you from a lot of complicated situations. Factor out the x, and then we've got a single x. Okay, is x all by itself? Thank goodness. Oh my goodness. Liam Neeson is feeling a lot better. I need to get a version of it. I should. Wouldn't that be awesome if there were a smiling Liam Neeson on the back? There we go. Smiling Liam Neeson. Now he's so happy. His ex is almost back by themselves. Okay, but is he completely happy about it? Not quite, because there's still a mess. The ex is still involved in a lot of things. So he's still on the phone saying, full disclosure, I haven't seen any of those movies, so I have no idea what he does or if he shakes like this, but I'm just imagining. He's very upset. Let my ex go. Okay, so then I know at this point keep soft things nearby to throw at the screen if you need to, because I know this is a ridiculously long and complicated problem, but you can do it. You absolutely can, because now I've got just a single x times this ugly mess, which I don't even begin to know what this means. I'm not even going to pretend I know what number it might be. But what I can do is I can divide both sides by it. Oh my goodness. So then I get log of 2 all over log of 5 minus 2 log 2 equals x. Yeah, 2 log 2 was a famous rap artist in the 80s. Yeah. So now what? Do we have x all by itself? Yes. Do we have a mess on the left? Yes. Can we be done now? No. See how it says round answers to 3 decimal places? This is the actual answer. So if I wanted an exact answer, you're done. But I didn't want an exact answer. I wanted an approximation because, oh my gosh, math professors, am I right? They just want and want and want. Okay, so here's the hideous thing. You guys are amazing. Look at what we did. All this. Wow. This is something you can write home, or if you're at home, you could just, write to a stranger and say, look what I can do. And the person probably respond with, who is this? And wow, that's amazing. So is Liam Neeson happy? Yes, he's happy, Liam Neeson, because X is by itself. X is back home where it should be. All the mess that was involved over here, all together. Okay, you ready to do some calculations? Okay, so I'm going to take log. Now, I can't remember whether I've shown this class this calculator. There are a couple different kinds of calculator. One of the ones that I like to use, let's keep it away from the light, Carol Ann. Some of them have a dedicated log and a dedicated natural log. And you know this is common log because it's got the 10 to the x above it. And you know this is natural log because it's got the e to the x above it. So these are great. I'm not using this, though. I'm using this one. I don't know why. I just felt like it today. And it's the follow-up to the Black Parade. This is the Black Calculator. In this, let's see if I can do this without taking out all your eyeballs. See how there's a natural log key? That means if I press it once, I get natural log. And if I press it twice in quick succession, I get common log. And because of that, if you do have one of these, since it's easier, you may just always want to use natural log when you can. If you get a choice. Like with this one, I just had to, oops, you can't see this. Let me move it over. I just had to apply one log to both sides. It could have been natural log. So if you have a calculator like this one that has the log and the natural log together, you may just want to go ahead with natural log. But let's go ahead and try it. I'm going to do it. It's not impossible. Okay, here we go. I don't know what the music to a Liam Neeson, it's probably him being very tense and shaking and getting fuming, right? He's seething. Ooh, Liam seething. Ooh. Okay, so let's see. It's very exciting. I'm going to do log of 2. And then for this one, see how to open the parenthesis? I need to close the parenthesis. And then you can either press equals, which I tend to do when I'm done with a numerator or denominator. I press equals. Okay, that's just the top. And then I'm going to divide by. See how it says the answer is getting divided by. Now, since the denominator has 2 terms in it, I need parentheses. So this is going to be parenthesis palooza. Okay. Parentheses. Log 5. Close the parenthesis for the log minus 2. Now here on some calculators you have to write 2 times log of 2. Some calculators you could just write 2 log 2. You don't have to, you can skip the times. I'm going to put in the times just to be safe. I need another logarithm. And then this one's 2. And then I close the logarithm parentheses, and then I close the denominator parentheses. The whole thing has to be in parentheses there. And we get enter, and then I get, he's so happy, he's happy, Liam Neeson. And that is 3.1062837 something else. And up here it says 3 decimal places. So 1, 2, 3, and I look at the 2 and I see that it's small. So I can approximate it with 3.1062837. 6. So what do you guys think? Kind of woohoo? Sort of woohoo? A little bit woohoo? Okay, there is another problem here. I'm going to just write on the next page. And I'm going to write out here. I'm just going to finish the answer. Woohoo! There we go. So far, so good. Happy Liam Neeson? Awesome. Okay, you guys ready to work on the second problem? Woohoo. More or less. Kind of. Maybe. If I say you have to. Okay, so this one is number 2. Was e to the opposite of x plus 1 equals 5.3. Believe it or not, even though this one has somewhat scarier numbers, it's actually easier than the previous one. So, okay, here comes Liam Neeson. Oh, he's so mad. X is all messed up in this big thing and we can't get it out. How are we going to get X home? Oh, okay, so he's going to use his logarithmic skills. Maybe his name is Logarithm Neeson. Liam Logarithm? Anyway, so upset. Okay, so what are we going to do? We know we're going to use logarithms. Why do we know that? Well, there's an E here. E stands for the exponential or Euler's number. This is the natural constant. This is this strange little cool little number. But 5.3 is not that number. And so the bases do not match. The bases do not match. Oh. So sad. Okay. Oh, Liam Neeson's so upset when the bases don't match. So what are we going to do? Well, we have an exponential expression. So it's an exponential equation, really. We're going to use logarithms. Now, if we already have an e in the problem, our best bet is to go ahead and use natural log, right? Now, in the previous problem, we didn't have an e, so we could choose natural log or log. It's up to you. But this one, we really want to use natural log. So let's go ahead and try it. So remember, if these two, the two sides of the equation are equal, then natural log of e to the opposite of x plus 1 equals natural log of 5.3, right? So let me use the same colors. What colors did I use before? I made logarithms purple. Ooh, that's exciting because they're magical. They're the unicorns of the math world. I don't know if that's true, but it sounded good. Okay, so let's see. What can we do? Well, it turns out this over here is just a number. It looks very complicated, but it's just whatever happens when you take the natural log of 5.3. So this side's actually going to be pretty easy to deal with. No x. Yes, but Liam Neeson's still upset because his x is up there and we gotta get it out. So what do? Well, there are two ways to look at this. There are two different properties that apply. We could use this property to bring this exponent down, but we also see that in this particular case, natural log and e are inverses. And so if they're inverses, they undo each other. So taking the natural log of e to an exponent is just leaves the exponent. Now, can I say they cancel each other out? No, I can't say that because it's not technically true. Could you say it? Sure. I mean, you could say anything you'd like. But really, in a perfect world, you'd say, because they're inverses, when you take the natural log of e to some exponent, the result is you just have the exponent left over. You have to use a lot of words. So you can't just say they cancel out. I'm not going to just cross them out with a red red line. That would be bad. Even Liam Neeson would be upset about that. He's willing to go to extremes, but he won't cross out natural log and e because, you know, he's got that core integrity. Okay, so Liam Neeson is starting to be happy Liam Neeson because why? Because X is down in the regular land. It's not floating up, you know, somewhere up in the sky. And so what we need to do is we need to say subtract 1 from both sides. And now this is really a little bit weird at this point, because to get X, we're going to have to take the opposite of everything. And a lot of people would just change the signs. I'm going to go ahead and I'm going to multiply by -1 just to show you how it looks. So -1 times the opposite of X is X. And I'm allowed to do this, right? I'm multiplying both sides by a negative. And then over here, I get the opposite of natural log 5.3 plus 1. So let me show you what the results are. If I take the opposite of natural log of 5.3 minus 1, I get 1 minus natural log of 5.3. So if you know how to go from here to here, awesome. If you don't, then multiply everything by -1. Okay, now we just use a calculator. Oops, sorry. Calculator to the rescue. How am I going to do this here? Pardon me, Liam. Go talk on the phone over there. There you go. There you go. Okay. So 1 minus, right? Natural log is on this one, the first one that I can click. So it's one click, very easy. 5.3. Now, do you have to close the parenthesis? Not on all calculators. I do try to make my calculator happy so that I don't take a chance that it'll give me something, you know, kind of weird. And I get -0.6677068821 ... And that's approximately equal to, remember, we're going to 3 decimal places, so I'm going to look there at that. Oops, sorry, you can't see that. We can move that over. I'm going to look right there to see what we're going to do. And 7 is big, so I'm going to go up 0.668, which is funny. I'm going to take this number higher, which actually, since it's negative, it's actually a smaller number. I know, you've been watching a video for too long. That was ridiculous. So again, what's going on here? These two are the exact answers. Those are exact solutions, and this is the approximation. And since you were asked to round, it's asking for an approximation. The good news is X is home where it belongs. So sad Liam Neeson is now happy Liam Neeson. Yay! Okay, so you know Liam Neeson is not going to be happy making just one video. No, we're going to have a lot of videos. In fact, we're going to have part 2, which is going to be Logarithm Palooza. So Liam Logarithm, no, I don't like that. Logarithm Neeson, there we go. Logarithm Neeson will be back in the next video, and we'll be talking about what to do when there are logarithms everywhere and you need to get your X back. So, woohoo. You know, go get some fresh air. Do something fun, stretch, get some exercise, maybe even rest a little bit. Come back fully hydrated, and we'll work on some logarithms. Woohoo! Math on. You guys are awesome.